So first thing, we have a new packet. You will get a new required practice, but just in case you lose anything, it's always linked on Canvas up here, so go there. You are going to have to, it's paper practice again. I asked you guys last time, let's please be better about keeping our work organized. You are not going to have room to do your work on this paper, and we made sure of it, okay? The back is blank, so you may use the back, but you're not going to be able to fit everything on the back. So, like this is the whole assignment for the whole unit. It's in chunks. You can see I drew an underline. I'll give this to you later. But expect to need some scratch paper to staple it together, and please try to keep it more organized. Label your problems 5.1. Work. Okay? So that way it's easier for me to check. I probably check every 2 days. I'll come around and make sure your progress. I don't know that you're going to have a whole lot of time today. In the back, I'm going to need you to stop talking over me. I need you to put your calculators down. I am not in the mood. Okay? Here's how it's going to look. We've got a lesson today, which is Algebra 1 topics. But again, it's a lot of ground to cover. We're going to do solving by factoring and solving by quadratic formula, which you did learn in Algebra 1, but it's been a while. I also have, again, I want to explain how I want to see your work. We're going to talk about solutions and things like that. There's some important vocab. So don't work ahead and listen to what I'm saying. Tuesday, Wednesday will be a probably brand new Algebra 2 stuff you haven't seen before because we don't go this far in Algebra 1. So be ready for that. It's going to be a fun time. And then end of the week, next week, it's just going to be a day over just practice. So if I don't get through all these lessons, or if you don't have a lot of time to practice, we are going to have a big chunk of that day to practice, but we do have a check for understanding we're going to do, and it is longer than normal. So we'll probably only have, maybe an hour or so, and then we'll take the last 30 minutes to do that check over solving. The second half of the unit, again, is not too much Algebra 1 stuff. This is definitely not Algebra 1. This maybe kind of is. But what I wanted you to really see was that your test, your Unit 5 test, is the Wednesday, Thursday before Thanksgiving break. So if you're leaving town or something, it would really be best for you to probably try to take that before you go on break, if at all possible, okay? Otherwise, plan to be here. It's going to be great, okay? So that is what Unit 5 looks like. It will go quickly. We are close to Thanksgiving, although it feels like we'll never get there. Yeah?
Will you have videos of
yeah.
classes?
Yes, and I have to record this period because last period I didn't press record. So that's also great. Okay, so here we go. Today's lesson is about how to solve quadratics, and we're going to go over two methods. We're going to go over factoring and quadratic formula. But just so you know what it means to solve a quadratic, if you ever see instructions that say solve quadratic, solve this quadratic equation, even if they don't label it, you are looking for the x-intercepts. That's what it means. Find the x-intercepts. What are other words for x-intercepts? Zeros, roots, and solutions. This is really where we call them more solutions because, again, that's what we're solving for. So we're trying to figure out where does our parabola cross the x-axis. There's three possibilities for the number of x-intercepts you can have. The first possibility is where your parabola crosses the x-axis 2 times, like this graph. That's the case where you have 2 real roots, zero solutions, whatever. I'll probably just pick whatever vocab word I start to write. Okay, and I put an emphasis on real. They are real numbers. They may be pretty numbers. They may not be. We're going to talk about how do you know if they're going to be rational or they're going to be irrational. But anything that crosses the x-axis 2 different times, whether the graph's concave up or concave down, you can have a possibility of 2. This is probably the most common, is having 2, but it's not the only possibility. The other one other one that you can have is where your parabola only crosses the x-axis, pretty much just lands on the x-axis 1 time. This is where you have 1 real root, x-intercept, 0 solution. This also happens to be your vertex point if it's this case, because that's the vertex of the graph. And we will be discussing these 2 cases today, but we're going to talk about the third case a little bit. We're not actually going to do solving with it today. Because, again, this is the break between Algebra 1 and Algebra 2. In Algebra 1, you probably said, what? No solution? Did you say no real solution?
No solution.
No, add the word real. No real solution. Okay? It does not cross the x-axis ever. And I've been emphasizing real because next class we're going to get into what it means. No, there's not a real x value that it crosses, but there are non-real values, and we will find those. Okay? What is a non-real? An imaginary. Like truly. I don't know. It's just a thing. It happens. Okay? It's a whole new number system. Something to look forward to on Halloween. Oh my gosh, if y'all are crazy now, y'all are going to be crazy on Halloween too. No Halloween candy until after school. Yeah, we do. Okay, hey, simmer down. All right, to solve a quadratic equation, I'm talking, also recording. Everyone's going to know how bad 4A is being right now. Okay, all right, to solve the quadratic equation by factoring, I'm not going to take as long on this page because we should be good at factoring by now. But this is the process here, factoring. Okay? Factoring will not work 100% of the time. Just know that. But I think if it does work, because I've been factoring for so long and I'm so good at it, and y'all will be too, I do think it is faster. But just understand that it is not always going to work. And we'll talk about how you can tell if it's going to work or if it's not in a minute on the next page. So all of these will work. All of these are factorable. On your test, I believe it'll probably be more structured because we are going to want to make sure that you can solve by factoring. So we probably will be specific sometimes on your test, like to use a specific method. But on these practice days, and we're specific on the homework too, but on that practice day next week, we're going to kind of leave it up to you. And make you figure out, like, how do you know whether you can factor. But again, I'll teach you how to do that. All right, step number 1. Anytime you're solving a quadratic by any form, you have to make sure that your equation is set equal to 0, and it needs to be in standard form. So it's got to look like this, okay? If it's not like that, you have to manipulate the equation before. When you're factoring, step 2 would be to factor the equation. Remember, we've got GCF factoring. We've got difference of squares factoring. We have easy factoring. And we have factor by grouping, box, whatever you do. So there's kind of 4 little classifications, and all of those are going to be covered here. What's new is going to be this actual solving, steps 3 and 4. But honestly, these steps are way easier than the factoring step. It's going to be the shortest amount of time is actually solving it. But I really think it's important that you understand the difference between just factoring and like when you stop versus actually solving, okay? So if you're solving an equation, these are all equations. What are these all equal to? 0. And if they're not, you're going to make them equal to 0. So this is telling you you are solving, you are looking for x. You are not going to leave your answers as x plus 3, x minus 5. You're actually going to solve for your x's, take it one step further. Now, I do want to see your factorization, but that's not going to be the full answer, okay? So here we go. We're going to do a couple of these together, the first 4. We'll do the first 4 together because they're kind of our 4 different types of factoring, and then I'll have you try some on your own. All right, number 1, are we set equal to 0?
Yeah.
Very good. We're in standard form equal to 0, so now we factor. This is a trinomial, okay? So it's possibly going to need like a lot of steps, but what's the first step always with with any factoring? GCF. Check for a GCF. Do we have one?
Yes.
What is it? 2. Okay, so when I take it out, I'm left with x squared minus 2x minus 15 equals 0. And then what do I do with that GCF? Bring it to the bottom, and I'm going to leave it in my factored form. Okay, now I'm going to talk about this GCF in a minute. Now I focus on my trinomial. Is this easy factoring in my trinomial?
Yeah.
Why? The a value is 1, so that means I can just number puzzle this and I can go straight to my factors. So what goes at the top of my number puzzle? Negative 15, because it's 1 times negative 15. What goes at the bottom? Think about those numbers. Negative 5 and positive 3. Okay, if you're going to use this shortcut here, be careful. Be careful. The number puzzles tell you exactly what goes into the factors. So if I'm going to put this number in, what does it look like as a factor?
X minus 5.
Minus 5.
X plus 3.
X plus 3. And what is this equal to? 0. Now I'm going to underline this right here. This is part of my answer. And on the problems that I want you to solve by factoring, I will ask for your factored form. So I'm going to label that as factored form. But have I actually solved it yet?
No.
No. So part of your answer, not the answer. Bulk of the work is done. Okay? But now what we're going to do is we're actually going to take each of our factors and set them equal to 0. So how many factors do I actually have here? I have 3. 2 is a factor. X minus 5 is a factor. X plus 3 is a factor. But let's talk about this 2. So it's a GCF. It is included in my factored form. I never want to tell you to get rid of a GCF in factored form because that is a big deal. However, if I were to take, because our step 3 is to set each factor equal to 0. If I were to take my factor of 2 and set it equal to 0, does that even make sense? Is there anything I can do there? So does this have any sort of effect on my actual solutions of my quadratic? No. So a numeric GCF matters in the factorization, but it doesn't matter in your solving. Look right here at my factored form. Could I technically divide the left-hand side by 2? Can I? I can. If I divide the left-hand side by 2, then what do I have to divide by 2 on as well? The right-hand side. But what's 0 divided by anything? 0. So you could divide that GCF over and that also see that it's not going to matter. But I do like you to keep it in your factored form because that is just really important in factoring, which is not going away. But it's not going to be an actual solution. Numeric only. Just a number. Your only solutions are going to come from factors that have x in them. So let's talk about this one here. X minus 5. That's a factor that has an x in it. I'm going to set that equal to 0. And then how do I get that x value by itself? Well, I move minus 5. I add 5. 0 plus 5 is 5. Okay? Y'all remember last unit we said in factored form we could see our roots. What did we have to do with the signs? We had to flip. This is why. You just didn't know you were doing that. You were actually moving that number to the other side of the equation, and that's why the sign flips. Okay? What about this one? X plus 3 equals 0. X equals negative 3. So here's your actual answers. X equals 5. X equals negative 3. 2 solutions there. Okay? I will warn you, with easy factoring, pay attention and don't just speed through it. The numbered puzzle tells you what numbers to put exactly in your factors. You do not do the sign flip until you do your solving. So be careful because people will flip the signs at the wrong time and it gets to be a big mess. Okay? So number puzzles slide into the factors. When you solve, that's when you actually do the sign flip there. And that's your answer. You're done. Okay? Last class, someone was kind of confused about how the GCF doesn't change the equation. This is a different equation here. Well, I'll do this one. 2x squared. I just want to show you graphically real quick. Minus 30 versus x squared minus 2x minus 15. So I put in y1. You don't have to do this. Just look here for a sec. I put in the original one with my GCF multiplied in. And then I put my second one with the GCF not even out in the front, okay? So technically, these are two different. These are not equivalent the way that I typed them. Do we understand why? Do you understand why these are not equivalent? Because I took the GCF out completely. But they're not the same graph. But look at what happens when I look at the actual graph itself. To the solutions. Here's my solutions on the first graph. Here's my second graph, not the same graph, but what are their solutions? They're still the same. So that GCF numeric value is just either making your parabola skinnier or wider, maybe flipping it, I don't know. But it's not actually changing what the x-intercepts are. So when it comes to actually solving this, that numeric GCF isn't going to throw off our work. We want to include it, but it doesn't actually affect our answers, okay? If you still need help with that, I can help you with that. But for now, let's jump to number 2. What are we factoring on number 2? Well, are we equal to 0? Yes. Now, we're in standard form, but our C value is 0 here. That's okay. I have a binomial. Binomials are easier to factor, quicker to factor than trinomials. There's kind of 2 cases, possibly a mixture of 2. But when you have binomials, you're looking at maybe it's GCF and done, or maybe it's difference of squares, or maybe it's a combo. Okay, that's what our brains need to be telling us. Especially moving forward, you're going to see a lot of binomials. They're quick. So let's check for what first? GCF. 4x squared minus 12x. Do we have a GCF?
Yes.
What is it?
4x.
4x. All right. Did we just take out a number here? No. We took out a number and a x. This GCF is going to act a little different than this one over here. What's left? 4x times x minus 3 equals, do not lose the equals 0. That is the tell that you don't just stop at factored form. This is our factored form right here. We cannot go any further. That's all we can do. But this is equal to 0, so I'm solving this. This GCF has an x in it. This means when it comes to solving that, it is going to give you a root because there is an x in it. So I'm going to take 4x and set equal to 0. And how do I get x by itself here?
Divide by 4.
What is 0 divided by anything?
0.
So if you have a GCF, no matter what number is in front of it, but there it is multiplied by x, you are going to have a root at 0. And it is a root. 0 is a number, people. It's there. It's the origin. What's this one?
X minus 3 is equal to 0.
And x equals?
3.
And I am okay if you guys go straight from the factor to what x is equal to. That's fine, okay? I'm trusting that you can do that sign change in your head. Also, I write these as x equals, but technically, just so you're aware, they are ordered pairs. So you could write it as 2 separate ordered pairs if you want. That takes a long time in my opinion, but it's possible. And then the other way that you could write it is a set, and that's a squiggly bracket with your 2 x values in there, whatever you get for your x's. But I'm perfectly fine with this. This is honestly what I do most of the time. Okay, there's like 3 hands up, so let's one at a time. Cool. If you take out a GCF with an x in it, then you will always have a root at 0. Yes, because you're dividing by whatever, and then that's always going to give you 0. Okay, we don't see it super often, but it can happen. And honestly, to me, this factoring is so easy, but like this is, if we do see this, this is what people miss. So you'll probably see it a couple more times because we're like, why do people miss this all the time? It's easy. It should be easy. Yeah.
So, wait, I don't know if this would still be a quadratic equation. So, what if
Time, numeric GCF doesn't change the x-intercepts. GCF with an x in it is always going to be a root at 0. Okay? All right, let's look at number 3 real quick. This is another binomial. Okay, because how many terms are here? 2. But does this have a GCF? Remember, binomials, we're thinking GCF. We're always thinking GCF. Does this have one?
No. Nope.
So what's your other option for binomials if there's no GCF? Difference of squares. Thank you. Difference of squares. What does that mean to be a difference of squares? Three criteria. Has to be a binomial. Check, check. Has to be a difference. So this guy's got to be minus. Check, check. Each term has to be a perfect square. Now, the factoring for this is so easy. That's why I love to put these on your paper because it should make factoring easy. Do y'all remember how it factors?
yes, you do the number
think so.
x plus 1 x
Square root of x squared is x plus square root of 25 is? And then the other one is square root minus square root. Can you put the minus first and the plus second? Sure. But it's 1 with the plus, 1 with the minus. Now, how many roots are you going to have here?
2.
2, because you have 2 different factors. X plus 5, what's that going to give you a root at?
Negative 5.
X minus 5 is going to give you a root at 5. And you're done. Okay? All right, last one we're going to do together, and you guys are going to do, actually, we'll do 5 together, and then you can do 4 and 6. What's wrong with 5?
It's not.
It's not 0.
It's weird.
It's not set equal to 0. So what do we do?
We are moving the 6 over and add the 0.
How do you move the 6 over?
You subtract it.
Boom. That's all you need to do. Hey, when it comes to moving, especially on your homework, there's a lot to move on the homework. Well, not a lot, but I feel like there's more than there is in the notes. Always, because we had this discussion last period because they moved it the other way. I always make sure that my squared term is positive. Even if I have to move like 3 things over, what? I stuttered a little bit. Quit laughing. Okay? Even if I have to move like 4 or 5 things over, I am going to make sure that x squared stays positive every single time. Okay? All right. Do I have a GCF here after I set equal to 0? No.
No.
Is this going to be easy factoring though?
No. No.
Why not? Not my definition of easy factoring. Because the a value is not 1.
Yeah, because it's not 1.
So you're going to have to do the whole process. So I wanted to do one of these with you because we haven't seen it for a little bit, although it was on your test. Didn't have 100% on that. All right, what goes at the top of the number puzzle? Negative 30. What goes at the bottom? Negative 13. Hold on, look at that. You got to get a negative 30 at the top.
Negative 15 and 2.
Yeah, this one is negative 15, positive 2. Okay.
Couldn't it be negative 10, negative 13, negative 3? Oh, no, never mind.
Not when you have a negative. You got to be careful with that one. This one trips people up. Okay, so as a reminder, here's what we do next. If we don't have easy factoring, we have to take 5x squared. Our number puzzles, we're going to put x's by those. Does it matter whether I put the negative 15 or the 2 first? No. It doesn't matter. That's what I like about grouping, is it truly doesn't matter. Could you be smart about it?
Yes.
Yeah, like 5 and 15, I'd probably put those next to each other because I already know they have something in common. Same thing with 2 and 6, but truly it does not matter. Okay? Bless you.
What would you do if you did it the other way?
It would still work. It's just you would have GCF. You would just have a GCF of x. And that's okay. 1x. And when you're grouping, you actually do want to take out, like even if it's just a 1, you do want to take out a 1. Okay? Don't forget to keep pulling down the equal 0. All right, so first group, at minimum, you can take out an x, but can we take out a constant with it as well? A coefficient, I mean. 5x, and then we're left with the second group. I don't know if I emphasized this enough last time because I had some people mess this up on the test. The second group is only a number. Whatever sign is in front of the third term, whatever sign is in front of there tells you what type of number, a positive number or a negative number. I sometimes purposely put positive numbers there if I have a choice. So I'm going to take out a positive what? 2. And that will leave you with x minus 3 equals 0. That second group, depending on how you set up your factorization, I think this happens on maybe potentially both 4 and 6. You have to take out something in that second group, even if it is just a 1 or a negative 1. This is kind of the one case where like actually factoring out a value of 1 is important, okay? And I think that's going to happen on one of these, depending on how you set it up. So what's my final answer, my factored form?
5x plus 2 times x minus 3 equals 0.
Okay, 5x plus 2 is the factor x minus 3 equals 0. This is your factored form. Now we have to actually solve it. This is the new part, but it's quick. X minus 3 gives you a solution at what? 3. What is 5x plus 2 going to give you a solution at?
Negative 2 or 5.
Negative 2 or 5.
Move the constant over. So 5x equals negative 2. But if there is a coefficient on x, you're going to have to divide it by that. So the other one is x equals negative 2 over 5.
Why can't you do constant first?
You did the constant first.
I mean, not constant. Why can't you divide by 5 first?
That's not following the correct order of operations.
Why not?
I thought it's multiplication and then addition.
Well, no. You're not. It's not PEMDAS. You're solving. You're doing PEMDAS backwards because you're solving. If you were like plugging in a number, you would have to multiply it first, but you're solving for x. So just like if I gave you, like this is like a 5x plus 2 equals 20, and I said solve it, you would say minus 2, divide by 5, divide by 5. It's the same thing. You're just trying to get x by itself, and you have to move the constant and then divide. Okay? All right, try 4 and 6 really quick. Ready, set, go. Or sorry, here's 4. Your factored form is x plus 1 times 6x minus 5. You have 2 roots, negative 1, positive 5 over 6. Number 6, you have 2 roots. Your factorization ends up being 5x minus 2, 3x minus 1. Your roots are positive 2/5, positive 1/3. This is what I was talking about right here. Can y'all see my mouse? Here it is. In this second group, depending on how you set it up, hush. Depending on how you set up your grouping, you could potentially have the second group where like you're just taking out a 1, which we normally don't do. But in grouping, we got to have a number there. Whether it's positive or negative, you've got to have a number there. This one was negative because this 5 was negative. But again, it just depends on which way you set it up. It could have happened on this group as well, depending on how you did it. Okay? So we need to be able to solve by factoring. You're going to have to solve by factoring. Like I said, I probably am going to tell you on your assessment at least one time to make sure that I can assess that skill. But if you have some leeway, factoring is an option. It's a tool in your toolkit, but it doesn't always work. So let's talk about how we can tell if it will work. One way that's going to happen is like if you can't figure out the number puzzle and you're like, I've gone through everything, it's not going to factor, okay? But there is another way to do it. Yes?
How do you find out on the calculator, the factors or something?
I'm probably not going to tell you that because I want you to be able to do that non-calculator.
Wait, I feel like I know how to do it.
You can always just start dividing numbers by whatever. But, okay, all right. Flip over here real quick. The next thing, hey, we're only halfway done. Paulina, hurry up. So the next section we're going to work on is how to solve by the quadratic formula, which we're going to do some practice in this. Again, this is Algebra 1. We're going to do more quadratic formula next time. Y'all are going to have to know the quadratic formula right here. It's not going to be given to you. You are going to have to memorize it. Do you know the song?
No.
Do y'all know? Yes, I always forget that. I always just do this. You know that little tune?
Goes the weasel.
Yeah. Okay, so that's how you can do the quadratic formula. I'll sing it one time, then you guys sing it with me.
I know it.
Okay. I do it a little bit different than some teachers do. So here's the version that I was taught by Miss Christopher way back when. Okay. Negative b plus or minus square root of b squared minus 4ac all over 2a.
But like, how are you supposed to remember the numbers?
You're just supposed to learn it.
Can you just give it to us?
No, I will not give it to you. So if you don't want to learn it, best of luck. Okay? So, we need to know that. But before we get to that crazy formula, in the quadratic formula, there's this expression that belongs in the formula. It is underneath the radical. What's a radical? The square root. But what I just highlighted right here, what I'm circling, is that, does that have a square root around it right now? No, in the formula it does. But when you talk about what this is, b squared minus 4ac, it is a number. And that number, depending on your formula, has a name. And its name is the discriminant. Okay, and I want to talk about this because this is a big deal. I am going to ask you to calculate a discriminant and then tell me what you know from that. If you tell me that a discriminant is a square root of something, I am marking it wrong because it is wrong. The discriminant is just the b squared minus 4ac. Just use that formula. Don't put a radical around it if you're finding a discriminant standalone. Okay, so we're going to go back to the formula, but right now I want to talk about this guy. There's 3 possible cases depending on what number you get, and you're getting a calculator to do this b squared minus 4ac, even though you can do it in your head technically, but you are going to get a calculator to do it for you.
Yay.
There is the case, yeah, you're welcome. There is the case where you have a discriminant, a number that is greater than 0. If a number is greater than 0, would you classify it as positive, negative, or 0? Positive. So here's what you need to know. If you punch your stuff in your calculator the right way, with parentheses, where they belong, which I will show you that in a minute, and you get a positive number, that means you will have 2 real solutions. That means your quadratic will cross the x-axis how many times? 2 times. I'm going to draw a concave up. I'm also going to draw a concave down because we just haven't done that as well. But here you go. Okay? Now, I want to talk specifically about this one as well because I said I was going to give you a way to know for a fact if something will factor. So technically, the number of solutions and the nature of the solutions would be 2 reals. But we can get a little bit more specific in this category, okay? It's still under the 2 real solution umbrella. If the number that you get, they both have to be positive, but if you end up getting a discriminant that is a perfect square, what's a perfect square? 16. What else?
25.
Okay. 24 is not a perfect square. 64 is. 36. Okay. You also have a calculator, so if you don't know, take the square root of it. Okay. Hey, okay. Thank you. If it is a perfect square, that means that your 2 solutions will be rational. Which means they're going to be a whole number or they're going to be a fraction. This also means if you have a perfect square discriminant, you can technically factor that equation. So if you're like, I can't figure out the number puzzle at all, calculate the discriminant. And if the discriminant is not a positive perfect square, then you're right. You can't factor that. Okay? If you get a positive number that is not a perfect square, which there's a whole lot more numbers that are not perfect squares than are. So if it's not a perfect square, it is not factorable, and that means you're going to have irrational.
What's irrational? Is that a negative?
No. It's like pi is irrational. Like the square root of 13 is irrational. Like just like a bunch of repeating decimals, not pretty. Annoying numbers, yes. We'll see a lot of them, but we'll deal with them. So this is not factorable. Can't factor. Because it's repeating. No, I think 1/3 is still rational, even though it's repeating. It's like I think I would need to look up the exact definition. But yeah. So pause on this real quick because we're going to kind of be living in this. Well, actually, let's talk about equal 0, and then I'm going to go back. So another quit, you two. Another option is if your discriminant is exactly 0. Exactly. You punch in your calculator, the number 0 pops out. Actually makes it a little bit easier for you. In this case, this is the only case that you would get 1 real solution. So this is the only way to get a 1, is if your discriminant is exactly 0. And it will be a parabola that crosses the x-axis 1 time. You could potentially factor these, may not, just depends, okay? So that would be an example there. And the third case, which we're not going to deal with today, but the third case is that b squared minus 4ac ends up being a number less than 0, which means it is a negative. And it would be a no real solution, but we're going to write what actually is going on. We're not going to talk about it today. We're going to write about it. It means you have 2 complex, you can also call those imaginary solutions. This is a next week problem. But I want you to know that today you are still going to have 2, but they will not be in the real number system. It's a different field of numbers. So you have a parabola that does not cross the x-axis in the real number system. It is odd, but it is not a today problem. Okay? It's a next week problem. So, real quick, before we move on to our actual quadratic formula, I just want to tell you, I went and calculated the discriminates of all the problems on the page before, which were all factorable. Okay? All of these guys here are factorable, but I calculated their discriminates. So I want to tell you what they are. We're going to do one of them together, just so you can kind of see how it goes. And then you can just take my word for the other ones and check my math later. But this is finding the discriminant is like something that it gives you an idea of what's going to go on. So your discriminant is b squared minus 4ac. I want you to watch how I write this. I'm on number 1 on page 2. I went back. Hush. The b value on number 1 is what? Negative 4. You guys, mega important that you are putting that b value in parentheses and you are putting the squared on the outside. I'm going to show you in the calculator how it will give you 2 answers if you don't do it right, and one of them is mega wrong. Okay? So negative 4 squared minus 4 times, what's my a? 2. What's my c?
30.
Negative 30. Okay, every number that I plug in, a, b, and c, what did I put around it? I do that for quadratic formula the whole time. Okay, for everything. So here I go. Negative 4 squared on the outside minus 4 times 2 times negative 30. And when I press enter, because this is factorable, because it has 2 real solutions, what type of number should I get?
A rational.
No.
Positive.
A positive perfect square. A positive perfect square. 256. How do I know if 256 is a perfect square? Second, square root, 256. Okay, so the discriminant, DISC, is 256. That is why this guy is factorable. It's a positive perfect square. Okay, I'm going to tell you what the other discriminants are. You don't have to write them down. I'm just going to tell you. Number 2's discriminant was 144. Is 144 a perfect square?
Yes.
Yeah. Number 3's discriminant was 100. Is 100 a perfect square?
Yes.
4 was 121. Yeah. 5 was 289. I had to check that one in the calculator. I didn't know that. But it's 17. And 6 was 1. Is 1 a perfect square? Yeah. Okay. So that's why all of these were factorable, because we got positive perfect square discriminant. So kind of cool. Okay. All right. Flip back over. If you didn't write all those down, that's okay. That was just more like food for thought.
What is that?
Just like good to know, you know? Just like brain food. Okay. I'm going to write at the top of this page, hey, we're running out of time, and I'd like for you to get some practice time, maybe some homework time, so stop. Here is our quadratic formula. Shush. I'm going to write it again. Negative b plus or minus square root of b squared minus 4ac all over 2a. You laugh. You're all going to be humming it on your tests.
What is the plus
You remember
over
people
minus
like when
mean?
you start saying it?
What is the plus? Humming it? Yes. Don't sing out loud. What is the plus over minus? What does that mean?
It could be both or neither.
Okay, remember,
Actually, one of the other.
let's talk about that. Most of our cases, close that. Most of our cases have 2. So one of those can be found negative b plus square root blah, 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 blah. The other one is negative b minus blah, 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 blah. There are going to be some times that we keep the plus minus together. There's going to be some times that we separate it out, and I will show you when to do which is why I want you to be listening to what I'm saying so you know what I want. Okay? All right, with quadratic formula, we have to make sure, I think I skipped over those steps, but just so I'll go back, you don't have to flip. You do need to still be equal to 0 in standard form. That does not change. I identify my A, B, and C value, and I always calculate my discriminant first. I think it saves time. Anshul, stop. I think it saves time in writing less. We always want to write less, especially with this big, humongous formula. So let me show you how I work these. I'm going to try to do a couple of them with you, and then I want you to try a couple on your own, okay? I'm going to try to show you one of each type. First of all, number 8, go ahead and set this equal to 0 because that was a typo. That happened on the homework too. Sorry. Okay? All right, so number 7, are we in standard form equal to 0?
Yes.
Okay? You still can, in quadratic formula, you can still check for a GCF. We'll talk about that on number 10, so hold on to that right now. Although you can still get the problem right even if you don't take it out. Your numbers will be easier to work with if you do take out a GCF. But we don't have one here. What is A?
9.
What is B?
1. 10.
What is C? That's the first thing that I do. And then I also go and I'm going to calculate my discriminant. Now remember, your discriminant is just b squared minus 4ac. Do not put a radical around it. So I'm going to write what I'm typing. And every number I plug in for A, B, and C, I'm going to put that number in parentheses. Oh, I forgot to show you why it doesn't work if you don't do the parentheses. Do y'all believe me?
Yes, I want to see.
Yes.
Let me show you let me see if I still have the one I just did. All right, this one right here. So I typed this correctly with the parentheses around -4, I get a 256. If I take the parentheses off,
Or just put the 2 and you get a negative.
or put the 2 in the parentheses. This is what people do most of the time, is just leave it off altogether. Or, like you said, this will do the same thing. If you put the 2 in the parentheses, you get not necessarily a negative, but you get a wrong number. It could be negative, but it's doing your order of operations wrong here. So you have to.
Would it like that specific number?
It's more about if you did this versus this. That's where you'll see a negative.
Yeah.
Okay? It doesn't, but either way, it's going to screw up your discriminant. And if that guy's wrong, it's all wrong.
Isn't
Okay.
-4 squared? Is that how it says 16?
Yes, that's why this is wrong.
Because it's doing
This is doing 4 squared and then a negative.
Ah.
Mm-hmm. So always put this in parentheses. So here we got 10 squared minus 4 times 1 times 12. So what's our discriminant here?
52.
All right. Is 52 positive, negative, or 0? Positive. So how many and what type of solution should we have?
2 real solutions.
We should have 2 real solutions. Now, extra work. Are these solutions going to be rational or irrational? Well, is 52 a perfect square? So these are going to be irrational, okay? So what I'm going to do now is I'm going to go to my quadratic formula, which again, because I've done this side work here. Yeah.
So I typed in my calculator and I got -4,800.
You typed a -4 instead of a -4. I guarantee you that's what you did. Okay? All right. X equals. I've been teaching this for 10 years. I know. I know. I also teach on level algebra 1, so I know. Okay? All right, here we go. That's why the song. -4ac. It tells you whether it's plus or, okay? All right, here we go. X equals, I'm going to the formula, negative. Again, I'm very careful with my parentheses. What is my B? Plus or minus square root of, guess what? We already did all that. What's going to go in the square root in the formula?
52.
Your discriminant, yes.
Happens in the square.
What do you mean what happened to the square?
You put -10.
Because it's not.
The formula, I'm in the formula now. Now I'm in the formula. Yes.
Why? How are you gonna why would it cost more money? Why is it not true?
Because we have 2 real solutions. So one of those is going to be with the plus. One of those is going to be with the minus. Okay? All right. Here's where my, yes.
Do you use that same equation if it has one solution?
Yes. And I'll show you that. It's going to happen here. Yes.
Wait, how do you know if it's the plus or minus?
You put them both in there. Just, yes, put them both in there for now. I'm going to show you examples where you separate them. Okay? But if you're getting irrational solutions, you're going to keep it together for simplicity. Okay? All right, so here's why I made you guys watch Nancy Pie. simplifying radicals, Nancy Pie? This is why I made you do that last time. Because this ain't going to cut it. Careful.
That's my bad.
Was that your head?
No.
Okay, good. This is on the right track. But if you want to get full credit, how are you going to write your solutions? This ain't simplified radical form. So, how do we simplify the square root of 52? Take out what? You can do the tree thing or you can do the perfect square thing. You pick your method, you got to know. 4 times 13 is 52. If you don't know what I'm doing, you need to go watch Nancy Pie.
Yeah, Matthew.
No, I need to know what.
The square root of 4 is 2. The square root of 13, you can't go any further. Did she show y'all that you can check this in the calculator?
No.
Okay, here is the square root of 52 right here. I simplified this to be 2 square root 13. I get the same decimal. So you should know if you did it right. Okay? So we need to clean this up. And we get that. So now I'm going to go back to my formula. Negative, and this is this is a positive 10, so I'm just going to drop the parentheses now. But if there was a double negative, I'd clean that up. I'm going to keep plus or minus together. Hey, y'all be quiet, please. You're going to get confused, and if you're talking while I'm teaching, I'm not going to help you. Plus or minus. I'll tell you to go listen to yourself being off task on the video is what I'll do. 2 root 13. That's just the simplification of the square root of 52 all over 2 times 1, which is 2. So I kind of like to show, again, this is where I plug everything in where it belongs. All right, now I'm going to simplify it down. And you're going to have to simplify radicals. 11 and 12, you have to simplify radicals. You'll have to know how to do it. It's not a suggestion. It's you're going to not get these questions right if you can't do it. We're still not all the way done. I'm going to circle 3 numbers right here. Pay attention to the ones I'm circling. I suggest you circle them too. What number did I not circle? Square root. We don't change that number ever. But these 3 numbers, negative 10, 2, and 2, what do they all have in common? 2. They're all divisible by 2. So if I divide every single one of them by that same number, this will be my final answer. X is equal to, what is negative 10 divided by 2? Plus or minus, 2 divided by 2 is, you don't have to write the 1. You can just write root 13. Do I have to write over 1?
No.
No, but if it was over something else, would I have to write that? Yes. And so, basically GCF those, yes. So, here's where you get your 2 solutions. I want you, if you do this, to keep the plus minus together, but here's what they are. Negative 5 plus root 13, negative 5 minus root 13. But I want y'all to keep them together if they're in this form. Okay? Did I answer your question?
Sort of. So do we always have to put like a plus or minus?
If you have a radical in there, I say yes.
What if it's the radical just simplifies out? Then what?
We'll do that on number 9. Okay? So I need y'all, like I said, I got a lot, and it's 4:15. So here we go. Let's jump to 8 real quick. Make sure you put 8 equal to 0, because it wasn't. All right, what's the A value?
1.
What's the B value? What's the C value?
25.
All right, the first thing we're going to do is calculate the discriminant. Write it out. B squared minus 4 times A times C. I know, it's a lot. It's all a lot. 10 squared minus 4 times 1 times 25. What's your discriminant here? What does that mean?
0. I don't know.
It's a perfect square, right?
What that means.
Look at your,
One
It's
solution.
negative, that means we have 2 fake ones.
no, it's not negative. It's 0.
X equals 0.
One real solution. 0 discriminant is the only time that you will get one real solution. Okay? So watch what happens here. I go to my formula. X equals negative. My b value is 10. Again, plus or minus. Square root of 0. All over 2a. What is the square root of 0?
0.
Okay, so really I have negative 10 plus or minus 0
Divided by 2.
divided by 2. Does plus or minus 0 do anything?
No.
So this is why you only have one solution. And where is your solution?
-5. -5.
You're done. So sometimes they can be rather quick. It just depends. We okay still? All right, let's talk about 9. This one is also kind of quick, but it is messed up right now the way that it looks. What do? We got to fix it.
Let's fix this.
Not factor, we got to multiply. So this will be 2x squared plus,
X minus 10.
are you okay to go ahead and move that in one step? Okay. All right, A, B, and C. Find the discriminant.
Square.
81.
That's perfect.
Okay, it's positive. That's the first thing. What does positive discriminant mean?
2.
Two real. Two real. You need to know the number, 2, the nature, real. So 2 real solutions. But what do y'all know about square root of 81?
9.
You can keep going.
Square root of 81 is
9.
9. Is this factorable if your discriminant is 81? Yeah, it is. But we're not going to do it that way, but it is. We're going to quadratic formula, and I'm going to show you here. This is a problem that we're going to split up the plus and minus because this is a perfect square. So let me just go back to my plug-in. X equals negative b plus or minus square root of my discriminant all over 2a. So I always like to see, and again, those of you that already know how to do this, great. You all should. You did in Algebra 1. But I hope you're listening for what I like to see when it comes to grading your papers. Because this is what I'm looking for. And this, if you want any sort of partial credit, you need to be doing it like me. So I'm up here. I'm modeling. Okay? So, what is the square root of 81? 9. 9 only. No more radical. There is always someone that includes the radical in there. Do not. The square root of 81 is just the plain number 9. So take it out. 2 times 2 is... This is the one case. This is the one case where if you have an actual number that's not in a radical anymore, I do want you to separate that plus and minus apart. I do want you to say, okay, I'm looking at negative 1 plus 9 over 4. And I'm also looking at negative 1 minus 9 over 4. Those of you that asked that question like 3 different times, does this answer it for you? If the radical drops out, I do want you to do that. What's negative 1 plus 9?
8.
What's 8 over 4? So one solution is at 2. What's the other one? Negative 1 minus 9 is?
Negative 10 over 4, which is...
Can you put a decimal for that? You could, sure. Here's your 2 solutions here. So if there's a radical still in it, don't need to separate it out. If there is, you can. Number 10 has a GCF. Again, with the GCF, I've kind of already had this conversation with y'all because it took so long last period. I had it prematurely with y'all. Again, I always move to keep my squared term positive, so I would do it like this. And I also want to put it in the right order. With quadratic formula, you can do this problem without taking that 4 out. It will just make your numbers a lot bigger, so it's up to you. If you do take the 4 out, as far as calculating the discriminant, that 4, remember we said the stretch, vertical stretch or compression, doesn't change the roots. So if you do take it out, it is okay to ignore it completely and just ABC, discriminant, yada, 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 yada from there. I believe this ends up being a perfect square. Again, it does. So you will do it kind of like this problem, but 11 and 12, I'm starring these because those have some radicals, especially 12. Those have some big radicals to simplify and then further simplify. And that's like big time where we need to get. So work on this. I'm going to come by and pass out your homework. I know we're almost out of time. I'm sorry. This is on Canvas if you lose it, but you're only doing 5.1. I drew a line between the sections. What?
Should we put answers on this or just on it?
No, I want everything. I don't want anything on this front paper at all. I want everything in a workspace. So 5.1 ends at question 9. 5.2 is 10 to 17. 5.4 is only 4 problems. So you can see that there. Also, y'all, number 6 should be equal to 0. Number 6 on the practice should be equal to 0, and it's not. Oopsies. Okay? Yeah, pass the papers over. Okay? Again, y'all need to keep up with your work and make it organized, please.